long ago and uses these gears to mechanically synchronize the very rapid jumping movements of its legs. This is the first demonstration of interacting gears being used by any animal. The jump is really very rapid indeed. It takes off at a velocity of about 5 meters per second. That's equivalent to about 12 miles per hour. And it accelerates in less than a millisecond. So it experiences enormous g-forces as it takes off, about 500 or even 700 g. I first became aware of these bugs when I was in the garden of my friend and colleague Peter Braunig in Aachen in Germany. He has a quite wild garden with lots of ivy growing all over the place. They're a very specific sort of bug. They only like to eat ivy. And so I spent a huge amount of time trying to look on all the ivy bushes in Cambridge for these bugs and couldn't find them. Then my 5-year-old grandson Max came to the rescue. He found these bugs in his garden and he rushed up to me one day and said, "Grandad, I found these plant hoppers in my garden. Here they are." And so we brought them back to the lab here in Cambridge, and that's when I did the experiment of showing that the cogwheels were actually engaging with each other. The high-speed images that we have to take of these bugs to reveal these very brief events takes us into a completely different world. 2 artists in London, Emily Tracy and Lizzie Hobbs, have collaborated with me on taking these films and doing a community project in Hackney in East London. So we've been interacting with a class of 9-year-old children from Gayhurst Primary School in Hackney, and with 2 groups of senior citizens called Ray's Geezers and the Sharp End. And that interaction has led to animating films of the creatures moving in the water. The children have been doing the animations, drawing the animals, painting them, and the artists have been assembling a film based on those pictures and on my pictures.
Three tails. He shows up really well.
I'm thinking we should move this into